This example belongs to another category, right? Obviously, this is category 3, right, where you need to find the compatibility conditions based on similar triangles. Okay. So here we have a rigid element ABCD supported by a pin at C and 2 rods at A and D. So if load P is applied at point B, then determine the stresses in rod 1 and 2, as well as displacement of point A and D. Okay. So here we are requested to determine what? To determine in the stress, normal stress in rod 1 and 2 and their displacement. Okay. For this, we just need to use F over A, and for this, we just need to use F L over EA. You can see that A, E, L have all been given. So again, this thing can be simplified into finding out the F. Right? So we're just need to find out F1 and F2. Right? How to find F1, F2, internal forces. How to find internal forces. For sure, you need free body diagrams. Right? This do we have enough equilibrium equations to solve F1, F2? If yes, it will be simple enough. If no, we need a compatibility equation to solve this indeterminate problem. Okay, so our first step will be free body diagram. Right? This first step will be free body diagram to try to find F1 and F2. Let's see what will happen. Okay, so the free body diagram has been shown here. Right, it's just shown here. Okay, this is our structure. The structure is here, and the FBD is here. Okay, you just cut it from here and cut it from here and make them free. Cut it here, then you will have F1, as shown here, F1 in rod 1, F2 in rod 2, and at point C, where you have CX and CY. At the point C, it's a pin support, so no M, right? No M at this point. So based on this free body diagram, we can write 3 equations for sure, or at least 3 equations. So the first one, if we look at F1, Fx equals 0, so we can have negative F2 plus Cx equals 0. Right? These are only 2 forces along x direction. Then the other ones, Fy equals 0. So how many forces do we have along y direction? We have Cy, P, and F1. Right? So we have F1 plus Cy minus P equals 0. Are these equations useful? Here actually, this is very tricky. Right? They may be useful, but you need more equations to solve it because we're just introducing more unknowns. Here in these 2 equations, we have 4 unknowns already, right? But we only care about F1, F2. We only need to solve F1, F2. So these 2 equations will introduce more unknowns to it. So they are not very good equations. They are not very useful equations. So they may not be useful. They may be useful based on your strategy to solve it. If you want to find out more equations, it could be okay. Okay. So our third equation, m equals 0, is m about which point? Right, this is the key step to solve this problem. Okay. See here, if you want to calculate m point D, let's see what will happen. If you select the point D, what will happen? If you select the point D, so you will have Cx, right? You have Cx, you will have P, and you will have F1, right? So two unknowns. So if you have, you will involve Cx again, but Cx is an additional unknown, so we will not need to solve, right? So how about if we select the point A? Right, if you select the point A, then you will have Cy, P, and F2. Again, you will involve Cy, so just additional unknowns. So it's not desired, right? So let's try C, right? MC. If we select point C to calculate M, the sum of M, then you will see what will happen. Okay. If you select the point C, then you will have F1, F2, and P. These three forces, right? This P is known, F1, F2 are unknowns. Right? So we can try to write this equilibrium equation based on summing MC equals 0. Okay, this will be negative. Let's see, anti-clockwise, counterclockwise as positive, right? So we'll have negative F2 times the arm will be C, right? The arm is C here. Minus PA, right? It's a minus PA. Then plus F1 times, what is the arm of F1? A plus B equals 0. Okay. So this is our equation 1. This is the equilibrium equation. This is derived from free body diagram. Okay, let's see what we can derive based on this equation. Okay, the C has been given. The C is here 300, right? This we use negative 300 F2 minus 80 kilonewton times 400. So here it's P times A, right? Then plus F1 times A plus B. A is 400, B is 350. It's a 400 plus 350 equals 0. Okay, so here we can derive that 2.5 F1 minus F2 equals 106.4 kilonewton. Okay, so this is our equation 1. This is the effective equation 1 that we will use to solve F1, F2 later. Okay, you can see that based on free body diagram, we just got one equilibrium equation, but two unknowns, F1, F2. Right? Then in the second step, so we'll just need to find out the compatibility equation. Right? We will examine compatibility. So which category is this? Category 3. Right? So we need to find a kind of correlations like delta 1 over A equals delta 1 over C. Right? So here, let's see which ones we're examining. Right? So here, we're solving F1, F2. So we will examine delta 1 and delta 2. Right? The delta 1 is the deformation of rod 1. And delta 2, delta 1 is what? Delta 1 is delta AB. Delta 1 here is delta A. Right? And delta 2 is what? Delta 2 is delta D, right, or delta DE. It's delta DE. Right. So let's see what can we write based on here. Okay, if you load this P, if you add this P, load P to it, so this A, B, C, D, this rigid element will be rotated clockwise, right? It will be rotated clockwise to here. Right? So we'll get such two triangles, and these two triangles are similar to each other, right? So here will be our delta 1, and here will be our delta 2. Okay. So since they are similar to each other, so we can write these proportional correlations between them. This is delta 1 over A plus B equals delta 2 over what? Delta 2 over C. Right? So this is the equation we can write based on these similar triangles. However, here is we have something to take into account. Right? We may need to add a negative sign to it. Because what? Because delta 1 is a positive number. Right? Because when you add this P downward, this rod 1 will be stretched. Right, so delta 1 is positive, but delta 2 is negative. Right, delta 2, the DE will be compressed. It will become shorter. Right, so delta 2 is a negative number. Okay, to be valid, to be meaningful in the similar triangles, so both numbers here should be positive. So I will try to put a negative sign here just before delta 2 to make sure we get a positive number here. Okay, so this is our equation 2, and based on this delta 1 is what delta 1 is here in this equation. Delta 1 equals F1 L1 over E1 A1, and delta 2 equals F2 L2 over E2 A2. Okay. So using the numbers, those numbers have been given here. Using these numbers, the first one can be derived as F1 over 23.333, and this second one will be F2 over, this is 23,333, and this here will be F2 over 416,667. Okay. So based on here, we substituted all of this stuff into this equation, then we can get a correlation between F1 and F2. Right, that will be F1 equals negative 0.14 F2. So this is our equation 2. Okay, so you can see that if we substitute equation 2 into equation 1, then we can solve these two equations. Right, there's two equations, two unknowns, both will be solved. Okay, if we do that, we will get, this will be our third step. We got equation 2 into equation 1. Then we can derive that 2.5 times negative 0.14 F2 minus F2 equals 106.4 kilonewton. Right. So F2 can be solved from this equation, and it is negative 78.8 kilonewton. And F1 will be solved that at 11 kilonewton. Okay, so here this is compression, here is tension. All right, then the work left will be easy enough. Right, just the stresses. Sigma 1 will be F1 over A1. That is 158 MPa. Right. Sigma 2 will be F2 over A2. That is negative 126 MPa. And then if we want to calculate delta 1 and delta 2, right, the delta 1 will be F1 L1 over E1 A1. Right. The result is 0.471 millimeter. And delta 2, of course, it will be a negative number. Right, it's F2 L2 over E2 A2. It is negative 0.189 millimeter. Okay, negative. So you can see that this is a critical point to realize that, okay, you need this negative sign. Okay, this negative sign is very critical. Of course, you can also ignore this negative sign, right? So then this result here will be positive. Then you just need to do more work here in this step than to derive the second equation. Okay, just need to be more careful. Okay, to derive the correct equation. Okay. So if you missed this negative sign, then this will be wrong. Okay, the result will be wrong.